Hello everyone, welcome to the second video on vector differential operator. In this video, we will see about solenoidal vector and irrotational vector. What do they mean and how can they be applied to problems? So we'll quickly have a recollection of what was done in our part 1 video. We defined del, the vector differential operator, as I dou by dou x plus j dou by dou y plus k dou by dou z. Now this can take an input either as a scalar or as a vector. If f is going to be a scalar that is given as an input to your del, then what gets generated is called as gradient, which measures the rate and direction of change in the scalar field. When you give a vector as an input, then there can be two kind of operations that can be performed by del, which is the dot product and the cross product. The dot product of a vector with your del will be called by the name divergence, and the cross product with your vector will be called by the name curl. So having defined these three quantities, we now move upon to define the next two qualities, what we call by the name as solenoidal vector and the second thing which we are going to define is called as irrotational vector. So what do you mean by solenoidal vector? We have defined the dot product with that of a vector f. If this dot product with the f vector, which we call it by the name, what do we refer it as? We call it as divergence. And if this divergence vanishes for all the points in a vector field, then such a vector f for which the function vanishes is referred as solenoidal vector, in which case the condition for a solenoidal vector now becomes del dot f vector equal to 0. So if I have del dot f vector to be equal to 0, what do you call this f vector as? F vector is called as a solenoidal vector. Next, what do you mean by irrotational vector? We already defined the cross product of this del with the vector f, and we refer it by the name called as curl. It measures the magnitude and the direction of rotation of a point in a vector field. So how much it can rotate is called as curl. So what do you mean by irrotational? It is not going to rotate, in which case the condition for irrotational vector now can be taken as del cross f vector equal to 0. So if del cross f vector is equal to 0 for all the points in a vector field, then this f vector will be referred by the name irrotational vector. So using this divergence and curl, we now define solenoidal vector and irrotational vector as following. When del dot f equal to 0 for all the points of f, you call f to be solenoidal vector. When del cross f is equal to 0 for all the points in a given region, then you call f to be an irrotational vector. The next thing is that whenever you have going to be your irrotational vector, whenever you have an irrotational vector, then what you can do is this f vector which you have over here can be expressed as the gradient of a scalar. Okay, so whenever f vector is going to be an irrotational vector, then we can express this f vector as an gradient of a scalar. What do you mean by gradient of a scalar? That is nothing but del f. So I can write f vector to be equal to del times of f, under which condition? If my f vector is going to be an irrotational vector. So keeping all these things in mind, let us move on to apply them to few problems. So let the problem be as such. Problem number 1. If my f vector is equal to y square minus z square plus 3yz minus 2x times of I plus, so second component is going to be 3xz plus 2xy times of j plus the k component be 3xy minus 2xz plus 2z times of k. Verify if this f vector is going to be both solenoidal and it is going to be irrotational. So our objective is going to be whether this f vector which has been given to us is going to be solenoidal and is this f vector irrotational. So to first check for solenoidal, so what is going to be the condition for solenoidal? If it is going to be solenoidal, then your del dot product with f vector must be equal to 0. So what is going to be del dot product with f? We know that del is going to be I dou by dou x plus j dou by dou y plus k dou by dou z. And when I take the dot product with f vector, then it will be dot product with f1i plus f2j plus f3k. We know the rule for dot product that I dot I is 1, so this alone will exist. J dot j is 1, so this alone will exist. And k dot k is 1, so this alone will exist. All the remaining mismatches will vanish. So we will be left out with dou by dou x of f1 plus dou by dou y of f2 plus dou by dou z of f3. What is my f1? This part with my I is called as f1i. This part with j is called as f2 and this part with k will be my f3. So substituting, what we'll be having is dou by dou x of y square minus z square plus 3yz minus 2x plus j times of f2, sorry, not j times, this is going to be dou by dou y of, so this is going to be dou by dou y of the f2 component 3xz plus 2xy plus dou by dou z component of what is going to be the third component 3xy minus 2xz plus 2z. Now we can differentiate partially with respect to x in which y and z are constant. A constant on differentiation is 0. So this term, first three terms will vanish with respect to x, leaving you with just minus 2 on differentiation with respect to x. Plus with respect to y, no y over here, so this term is a constant on differentiation is 0. This term with respect to y will give me 2x as the constant, y on differentiation is 1. Now coming to the third term, over here with respect to z, no z over here, so this will vanish entirely. The next term with respect to z minus 2x is going to be my quantity, z with respect to z is 1, and the last term is 2z with respect to z will give me plus 2. Now we can notice that this minus 2 cancels off with this plus 2 and this plus 2x cancels off with this minus 2x, leaving us with a scalar of 0. So I have del dot f to be equal to 0. So what can you say about this f vector? F vector is going to be solenoidal. So I have completed the first part. What is the second part? Irrotational. They are asking us to show whether f is irrotational. What do you mean by irrotational vector? By irrotational, we mean that our cross product del cross f vector must be equal to 0. If it is equal to 0, then f vector will be called as irrotational vector. So let us go for the cross product. What are the components now? I is the first component. For del, it is going to be dou by dou x, and f, what is going to be the first component? The first component is going to be y square minus z square plus 3yz minus 2x. So this is going to be my x f1 component. Next my j, dou by dou y. What is going to be my F2 component? My F2 component is 3xz plus 2xy. The last comes my k component, dou by dou z of, what is going to be my k component? 3xy minus 2xz plus 2z. So I need to find the 3 cross 3 determinant of this quantity. So for the I component, what you will have to do is hide your row, hide your column, cross multiply the remaining two vectors. So this will give me I times of dou by dou y of the quantity 3xy minus 2xz plus 2z minus dou by dou z of, cross multiply, 3xz plus 2xy. So I have done with my I component. Minus j, second term is always a negative term. What happens over here? Now hide the second row and the second column and then take the cross multiplication of these two quantities. So you will have to multiply these two quantities. So it is j times of dou by dou x of 3xy minus 2xz plus 2z minus dou by dou z of y square minus z square plus 3yz minus 2x. And last comes the k component, k times of, now what we'll have to do is hide the last row, hide the last column and take the cross multiplication of the remaining two component, in which case we will be having dou by dou x of 3xz plus 2xy minus dou by dou y of, what you will have is y square minus z square plus 3yz minus 2x. Now we are ready for the partial derivative. I will do the partial derivative over here so that we will be easily estimating it without turning back to the pages. With respect to y, with respect to y we have 3x, this is no y, this is no y, minus with respect to z I have 3x, so this becomes 3x, this doesn't have a y so it vanishes, plus minus j times of the second component with respect to x, this is going to be 3y, and the second term with respect to x I have minus 2x, minus 2z with respect to x, and the last term doesn't have an x so this goes off. How about the third one is minus sign of this minus sign with respect to z we have. This z gives me minus 2z, so minus 2z, and now here you have a z, so you will have minus sign of 3y. Why do we take a minus sign? Here you have a minus sign, okay, and plus the last component doesn't contain an z, so this vanishes. Next, with respect to k, we have k times of, what happens with respect to x, this contains an x, so this becomes 3z, this contains an x, so you will have 2y, this with respect to y on differentiation will give me minus 2 times of y, this doesn't contain a y, this has a y, so you will have minus 3z, and this doesn't contain a y, so it vanishes. Now we can see or notice that this 3x and 3x vanishes, making it as 0 times I, 3y minus 3y, minus 2z and minus of minus plus 2z vanishes, making it as 0j, 3z minus 3z, 2y and minus 2y cancels off, leaving you with 0. So what do I have finally is my del cross f vector equal to 0. So it is a 0 vector. So what do you call this f vector as? It is an irrotational vector. So for the given problem, we have proved that f is both solenoidal as well as irrotational vector.